Hello, my friends of Hatari Labs. My name is Saul Montoya. Please welcome to this webinar, and the webinar is related to the modeling of mixing water from water and an effluent with OpenFoam and HatariUtils. For the purpose of this webinar, there are some software that we have that we need installed. That is Salome. Paraview, Salome is optional because actually it's only to see the mesh is already built, so that is why uh, we are not going. It's not that required. Okay, Paraview, yes, because we are going to see the results through Paraview, and then we need an account on Hatari Labs. Okay, on HatariUtils. Okay, great. So if you don't have an account in HatariUtils, please make it, okay? And if you don't have Paraview, please install it, and that's it. Okay, and please place the content, okay? The content of this webinar, please place it under the document, okay? Because it's important to be there, okay? If you are here with me, please type 1. Mhm. Who else is here with me? Okay, let's see. So we need to have OpenFOAM installed, okay? And in order to have OpenFOAM installed, Bohin, I will ask you, do you have Ubuntu OpenFOAM installed in your computer under a Windows subsystem for Linux? Please type yes, please type no. Okay, so first let's go to store. Let's go to store, and here on store we are going to work with Ubuntu, okay? And there are many versions of Ubuntu here. I have tried, I mean, and this is this will be different in next year or so. Okay, so, but for the version that we know that OpenFOAM runs is version 22.4.2. Okay, because there is also this version, but we are going to install. Please install this version. Okay, everybody install this version, and once you have installed it, please type open. Okay, please install the version, and once you have it installed, please type open. Please type 2. Please type 2. Ah, sorry. Uh, you cannot see my screen, but this is recorded. Okay, great. So let's go. Okay, I will repeat again. So let's go to store. Let's go to Windows Store. Okay, let's go to Windows Store, and let's type Ubuntu here. And let's select this one. And once you have it selected, just open that, okay, and type 2 on your computer. Okay, once it has downloaded, please type open. Please open that and type 2. Bohin, how are you going? Ana Paula? Okay, great. So I will wait for you. Ah, okay, Ana Paula. Sorry to hear that. Okay, Boyin, we are working with you. And there is another guy, Andres, I guess. Okay, Boyin, how are you doing? Ah, okay. Okay, I will up. Okay, yeah. So on your installation, okay, it will ask for the user, okay, and for user is Hatari, and for the password is labs, okay, that's it, okay. So it's Hatari, the user, and labs. Okay, so you will end up something with something like this. Okay, so we have to install OpenFoam, and the version that of OpenFoam that we are required is version 9. Okay, why version 9? Because the it is really hard to no, I mean because I see that the OpenFoam is already in version uh, 11, but the solver has changed. So actually, we haven't adapted to the new solver. So that is why we are just working with the previous with the solver with the 9 version. Okay. So in order to do that, so we have to get a key. So in order to get a key, so we are going to get the key. This is on the chat. This is on the chat. Okay, and this will be labs. Okay, labs is the password. Okay, so what we got the key. Okay, and then we add the repository of OpenFOAM because OpenFOAM is actually not in the normal repository, so we add the repository. That's it. Enter. Okay, it does a sudo apt-get update, and then a it does the update and it also adds the repository. Okay, we do another update. Okay, great. So, and then we install OpenFOAM 9. Okay, so we install OpenFOAM 9. Okay, all the commands are on the chat. Okay, great. Mhm. So finally, in order to have all the executables of OpenFOAM, uh, all the executable of OpenFOAM available from the command line, we need to tweak the bashrc, and then at the end of this file we have to add this line, okay, OpenFOAM. Okay, and with that what you do is that you make OpenFOAM available, I mean the all the executable for OpenFOAM available on the command prompt. Okay, Control X, yes. Okay, and then once you have done this, okay, you have to reinitiate your bash rc. So you do this, okay, and with that you can, for example, you can say intermixing foam, okay, and it will say, but this intermixing foam is a executable of OpenFOAM. Okay, so you can say interfoam, okay, and that's it, no? Okay, and we can also say foam run help. Okay, foam. Mm, okay, there are foam new, foam, hmm, foam version, for example. Okay, OpenFoam 9. Great, great, great. Okay, so let's talk about okay, so the meshing option, and we are not going to cover the meshing option here. This meshing option is done in Salome. Okay, but we can discuss about the meshing option. Okay, great. So here, if you have any questions, let me know, because actually I think that maybe for the installation you will prefer to see the video. Okay, but if you have any question that might arise, that will be the the time to ask for that. Okay, we have already created a mesh. Okay, we have already created a mesh. Okay, so if you go to the webinar folder, if you go to the webinar folder here on documents, okay, if you go to the webinar folder, we have the a geometry. So here we go to geometry. Okay, and on geometry we have this is our geometry, where here we have the inlet, we have the effluent, and then we have the outlet. We have as well the atmosphere and the walls. Okay, so we can go here to mesh. We can go here to mesh. Okay, and on mesh I can, for example, I can add mesh 2. This mesh 2 has a, this one has a, okay, what is the difference in between mesh 1? The mesh 1 has no refinement, while the mesh 2 has a refinement. We can work with any of them. Okay, so what we are going to do is we are going to see the faces. Okay, so here we have the inlet, then we have the inlet 2. This is where the effluent will come. Okay, this is the main river, and then we have the outlet. This is the outlet, and then we have the atmosphere, and this is the atmosphere. Okay, and then we have the walls. Okay, and if we want to export this in a format that is compatible with OpenFoam, we have to export as a UMV. Okay, and on the folder we have already, okay, so here on the, we have the river to UMV. Okay, if you are follow, okay, I know that it will be better because there are many stuff that you follow the video, but if you follow me through here, if you have any questions, okay, but if you follow or everything is clear, please type 2. If everything is clear, please type 2. Okay, great. So, okay, so what we need, okay, now is to work with HatariUtils, okay? Because this is the geometry, but we are going to associate the boundary conditions to this geometry. Okay, so let's see and let's work with HatariUtils. Okay, so here we are going to use, okay, and this you can do anybody of you because this is not no software required. You have to sign in. Okay, I will delete. Okay, and then I will create X webinar. Okay, because this will be the example of the webinar, X webinar. Okay, so this is the example of the webinar in HatariUtils. Okay, and then we edit this. Okay, what is HatariUtils? HatariUtils is a bunch of tools where we have here the CFD option that is for intermixing foam. we are going to have another one for interphone as well. Okay, and then here we have to work with the boundaries. Okay, so in the boundaries, okay, so here in the boundaries we have five boundaries. Okay, because the walls, the inlet one, inlet two, the effluent, no, the inlet one, the inlet two, the outlet, the atmosphere, and the walls, there are five boundaries. So here those are five boundaries. And here we are going to type inlet 1, inlet 2, atmosphere, outlet, and then walls. Okay, great. If you are following me through here, please type 3. If you follow me through here, please type 3. Okay, great. So here we define the five boundaries. Okay, so this will be inlet 1, inlet 2, atmosphere, outlet, and walls. Okay, great. So in inlet 1 will be fixed value. The inlet 2 will be flow rate inlet velocity. This will be pressure outlet velocity. The outlet here will be zero gradient. Okay, and this is no slip. Okay, this is how it works. The the velocity of inlet 1 is 1. The inlet 2, that is effluent, is giving 1 cubic meter per second. Okay, and the atmosphere is actually not giving any water, any air. Okay, the velocity is 0. Okay, you can try with the other, with playing around with the other boundary conditions. Okay, in this case, this is how it works for us. Okay, but we know that there is, you can always play around with the parameters. Okay, Boyin, if you are following, or anybody else, anyone else, if you follow me through here, please type 4. If you have any questions, let me know. Oh, great. And then we have the row GH, that also for the inlet 1, inlet 2, atmosphere, outlet, and walls. Okay, and everything here will be zero gradient except atmosphere, that will be total pressure of 0, and the outlet will be total pressure of 0. That means that water will just arrive to the outlet and just leave the. Okay, that's it. If you are here with me, please type 5. Okay, so these are the, and just type save. Okay, so if you are following me through here, please type 5, and this is just how you are going to do. And then let's talk about the air. The air is zero gradient, zero gradient. Okay, this will be inlet 1, inlet 2, atmosphere. Okay, with this app you actually have just to select. Okay, but before you had to type into the different input files of OpenFoam, and this was really so painstaking. Yeah. Now, okay, so the air, it means that the air could come from the atmosphere, because the air cannot live through walls, for example, but it's 0. Okay, so in the in the on the top of the model. Okay, if you are following me through here, please type 5. Okay, great. See. And then here we have the alpha water that is okay. Inlet 1, inlet 2, atmosphere, outlet and walls. This is uh, inlet outlet, inlet outlet, inlet outlet, inlet outlet. Zero gradient. So it means that from the alpha water cannot go through the walls, and then one and one. Okay, and then there's alpha order. In alpha order, there's also inlet 1, inlet 2, atmosphere, and then outlet, and then walls. Okay, we have a Patreon repository for all our webinars, but this one will be available on the internet. Okay, so this won't be posted on Patreon. But if because this kind of is innovative and really there is few people here, okay. But if you want to support our research, you can join us in Patreon because this really help us to continue doing this interesting stuff. Okay, so this is alpha for other. Okay, save. Okay, and then we are going to, okay, what we have done is we have said, okay, from the different boundary condition, what is, I mean, which kind of liquid is coming from each boundary conditions. Okay, this is what we have done in alpha air, alpha water, and alpha water. Okay, but by default, all water, all the model is filled with water. Okay, but we know that there is a part that is on the effluent, that there is a part that is filled with effluent. Okay, so that is why we are going to create one region that this one will go to the set fields dict for the people that are fluent with OpenFoam. Okay, so this will be 1 minus 5 minus 1, and this will be 110 minus 0.1 and 10. Okay, 0, 1, 0, air, other, water, 0, 1, 0. And let's save. Okay. And the model will last for 20 seconds. Okay, it can last for more. And then you will have results every second. Okay, great. So just type upload. Okay, so and then say create and download files. You want to create files? Yes. And then you want to download those files? Yes. And then you download that. And by downloading this, so here on my downloads, okay, I will, okay, I will download it again. Hmm? Okay, here I will download. Okay, I will extract here with the WinRAR. Okay, and then here on webinar, I will take the case folder, Control C, and then I will paste it on the webinar folder. Okay, great. So here we have the case folder. Okay, and then we have pasted here under webinar folder. If there is any question, please please tell me, or if everything is okay, please type 6. If there is any question, let me know. If everything is in order, please type 6. Okay, great. So let's go here to the, okay. So this is Ubuntu, okay? But Ubuntu, your C drive is actually a mounted file here in Windows Subsystem for Linux. So what does it mean? So we can change to slash mnt, and then this is C, and this is users, and this is my user. For your case, it will be another user. So we go to documents, so we go to the webinar, okay, and then we go to the case folder. So with that we are changing to this case folder is where all the values are, okay, where all the values are. Okay, so, okay, great. So now we are here, and then we have to create the mesh. Okay, so the mesh is as a UMV. So there is a executable of OpenFoam that is ideas UMV to foam, where we can, okay, and what this does. Okay, so here in system, no, here on constant. Yeah, we don't have the geometry yet, but if we do ideas to env, okay, upper directory, mesh rio, mesh rio, no, no, rio 2, rio 2.umv, okay, this will create the the faces, it will define as a patch, and it will see how many faces are for this, how many patches are for his faces and so on, and this will create here on constant, it will create this polymesh. Okay, amazing. Mhm. With the boundaries, with the phaser, with the neighbor, with the owners, and the points. Okay, so everything is here, and this is imported from the UMB. Okay, the second thing that we have to do is that we have to do set fields. Okay, set fields, because this will on the set field folder, on the set fields. Okay, so here on system, on the set field disk. Okay, by default we have said that everything is water, but we are saying that on the region there is effluent. Okay, so that's why we do set fields. Okay, great. Okay, so there is a third quest there is a third part here, and the third part here is that we have to do, yeah, now we can run intermixing foam. Intermixing foam, okay, and with that, okay, we are running the model, okay, and then we run the model. Actually it's pretty okay. The Salome actually takes so much resources, so we are going to take it out. Okay, okay. Well, and streaming and recording also is also taking resources. However, we cannot do much about it. Okay, the current number is 0.01, and the total time is 0.1. Okay. What else I can do? Okay, I can close this because actually I'm not going to work with that anymore, and then I can also close this, and I will close as much windows as I have. Okay. Um, Actually, it's pretty. Yeah, I know why it's so. Because we are running mesh 2 that has more. Because mesh 2 has uh, more cells. Okay, that is why it's more. But okay, what we can do. Okay, because this is going to take time. Uh, we are going to Control C. We are going to recreate that again. So we are going to close this. Okay. So, and because the process, okay. So first of all, I'm going to delete case folder. Okay. I'm going to delete this, and then I'm going to paste it again from the file that I have. Control C, and then here case folder. This is an again case folder. Okay. In this case, nothing will. Okay, and now I have to run ideas when to the Rio 1 that is a mesh that is lighter. Okay, and then set fields. Okay, so we do set fields, and now we do the intermixing foam, and in this case we have something more that runs faster because it runs I mean that it has a lower resolution, but it actually runs faster. Okay, as we see, yeah, now we have already 1 second, okay, 2 seconds, and this is much faster because you can do as well the compose part. That means that you can run uh, with many cores, okay, but in my case, I cannot do that because it's actually doing streaming, and streaming also takes some resources on the computer, so it will block the streaming as well. Mhm. Okay, now we have 5 seconds. Let's wait till we have 10 seconds. Okay, so let's see. And the current number, the delta t is 0.02. We have 6 seconds. Uh, what is the question, Andres? You can open the mic and ask for them as well. Which is the question? Okay, now we have 8 seconds. Okay, now we are close to the number 10. Once you are in the number to the 10 seconds, what you have to do is you have to do Control C to stop the. Okay, great. So this is already the simulation for 10 seconds, okay? And there is something that we can do that okay, because what you have until now is that you have whether you have water or whether you have your effluent, but you don't have a concentration, okay? So in this case, in order to have a concentration, you have to, okay, you have to run a Python script that calculates the concentration. So this is why we do Python 3 component calculation, okay, because component calculation is a Python script that is here, and it will ask which is the folder. Is this one, okay, that it has a 10, it lasts for 10 seconds, and which is the concentration on the main flow. Let's see that is 1, and then effluent is 15, okay, and with that is doing the calculation for calculating this. Okay, actually this script is related to this type of case. Okay, if you are going to work with more boundary conditions, or your boundary conditions are going to be with different name, like you maybe you will have errors, but uh, our recommendation is that you follow this through here, okay, and then when you, this is kind of new, I mean this kind of procedure is not that common, okay, and I think that by doing this tutorial step by step, you are going to excel this uh, OpenFoam step by step as well. Okay, yeah, you need some UMV. Okay, there is a question from Andres that says that you need to UMV. These files are done with Salome. Okay, and as well you need the UMV from Salome. Actually, the HDF is not required, but well, it's worth to have it because you can maybe change your project. Okay, and then what you have here, or then what you need is the case, and the case folder is that something that you download from HatariUtils, okay, and these are the two files that you are required for the simulation. Okay, so let's open Paraview. Okay, and since the project, the case folder has this parafoam, okay, all of this can be seen through Paraview. Okay, okay, so let's see, we can open file, open documents, webinar, case folder, no, case folder, yes, parafoam. Okay, so let's see, let's plot the water. Okay, this is the water. Okay, and this is the water. Okay, let's plot the other. Okay, and let's plot the component that are the concentrations. Okay, that is similar to the other. Okay, however, on the component, you will have what on the component you will have here. Okay, you will have here the values of component. But what is more important to us is to have the contour of the concentrations. Okay, and in order to have the contour of the concentration, okay, so we need to use this one, but this one is actually not that big, not that well. I mean, because what we have are the values on the cells, but we need the values on the points. Okay, so we have to do one step more, that is go to here to filters, and then we look for that filters, search cell data, and then we look for cell data to point data. Okay, and on cell data we do apply, and then we are going to do this filter over alpha component. Okay, and that's it. And then from that, do you remember that the concentration on the main course, I think that it was 1, and the biggest one was 120. So we are going to do contours over that, okay, for the alpha component. Okay, 1 to 15. Okay, no, it was 1 and 15. Okay, and then we do all these contours, and then we take it out, this one that is so ugly, and then we do apply. Okay, and these are the contours, and this is really similar of what you had at the beginning. Okay, and here on the model we need the wireframe because I want to see the geometry, or geometry as a solid color. Okay, and then here we can see the how is the effluent mixing with the water, and then we can see which is the extent of the mixing. Okay, and how it lasts through the time, because this is only 10 seconds. Okay, but you can do it for 120 seconds and so on, and then you can evaluate this mixing. Okay, and this is entirely done with, if you see that the effluent goes a little bit down, is because here on system, no, on constant, in moment of properties, the effluent is a little bit, has more density than the has more density than the norm than the water. Okay, you can set it up as to have the same density, and then you will have different results. Okay, so my recommendation is that you play with this, that you right now I'm going to send you the link of the video. Okay, play with that, and I think that that will be a great idea. It will give you a great idea how to work with OpenFoam to model mixing water, and then yeah, we are going to work as well in another applied cases. Okay, so I'm going to stop the recording.